Good day, students. Today we're going to look at some examples of changing logarithms to exponential form and exponential form to logarithms. This is part of practice 1, which is page 123, chapter 5, book 2 of math 1026. Now this whole chapter, chapter 5, deals with logs, or logarithms is the full word, okay? And all logs is another way to rewrite an exponential equation or function. Now, if I told you let me just make that a little bigger. If I told you an exponential function 2 power of 3, we know that to be 8, right? 2 cubed equals 8. And we know this to be a true exponential form, isn't it? So this is a true statement, and we call this exponential. Okay, now to rewrite that in logarithmic form means to isolate the exponent. Okay, so we use the abbreviation log for logarithms, and we write the base of the log as a subscript. Subscript means to bring it down slightly below the line. So don't have it in the same line, bring it down slightly below. So this becomes log of the base, and the base up there is base 2. And then of the value of the expression above equals the exponent. So when it's in log form, what do you notice? You notice that the exponent is isolated when it's in log form. This is the exponent. Okay, now you should know from up here that the 3 was the exponent, right, in the exponential form, right? And the 2 we call the base. Now, for lack of a better word, I just call this the value of the expression. Okay? And every time you change from either log form back to exponential form or exponential form, you have to know positioning is quite important. Okay? So you have to understand that. Now, that looks kind of messy, so let's just get rid of that for a second and show you that one more time. So, if I had 2 to the power 3 equals 8, if I change that to logarithmic form, log base 2 of 8 equals 3. Okay? That would be the correct form in log form. So if we did it in just general letters, so every time you write an exponential function, you have a base, you have an exponent, we'll call it e, and equals a value. Let's call it v for value. Okay? So this is bev. We'll call this BEV, bev. So when you switch from BEV, or base exponent value, it becomes log. Now where does the base go? The base moves down as a subscript. Don't write it in the same line. The value moves over here, equals the exponent. So all a logarithm is an exponential equation rewritten so that the exponent is isolated or by itself. Okay? Now, let's answer, based on that, let's answer our questions here. So let me get rid of that. Alright. Okay, let me just rewrite that down here so you can follow the switches. Hold on, let me get my pen working again. Okay, so remember, if we have b to the e equals v, then that becomes log base b of the value equals the exponent. Okay? So the very first one, now let's look at number 1g. This is all from number 1. Now 1g says 64 to the 1/3 equals 4. Well, let's just double check and make sure that's a correct statement. Okay, now I just brought up the calculator there, so I'm going to put in 64. I'm going to raise it to the power. See the arrow there? That means to the power of. Now if it's a bracket, or put brackets I should say, around the exponent, if it's anything other than a single number. Okay, whoops, I forgot to divide it by 3. 1 divided by 3. So 64 to the power of 1/3. What does that equal? And it does equal 4. Okay, so we have a true statement up here, don't we? Now, how do we rewrite that as log form? So these are all true statements. You can check them all on your calculator. But how do we switch that to log form? Okay, now remember, it's log. Now what's the base up above? Identify the base. The base is 64. Well, that's the one that moves down as a subscript of the value. Now the value goes in the same line as log. of the value equals, right, the exponent, and the exponent is 1/3. So see how I rewrote that. Next one. Okay, identify the base. So let's do that this time. Let's identify each part of that exponential equation. This is called the base. Alright? B-A-S-E. 3/5 is called the exponent. And I'm calling 27, for the lack of a better term, the value of that expression. Okay, so we have all the parts there now, right? Base. Now how do we go about, okay, changing that to log form? One more time. So what do we have? Log, I'll identify the base, 243, written as a subscript, move it down, of the value equals the exponent. So all we're doing is practicing switching. Switching is important for later when you're solving log equations. Okay, so you have to know how to switch. And the last one in that form, alright, again, log, what's our base? That's right, base is 16. What's the value of the expression? It is 8 equals the exponent, which is 3/4. Okay? Now, I'm going to take that and I'll move it up here out of the way. We'll do these. Now, the next group, what do I have to do? What form is it in? So the next three are all in what form? As you see them there, look. They're all in log form. So now we're going to work backwards. We're going to take it in log form and put it back in exponential. That's what they want us to do. So really there's a double arrow on this, isn't it? Because we're going to switch from log form to exponential, exponential, back to logs, and so on. So now we want to do it this way. We want to switch from log form to exponential form. So we're going this way. Now, again, you have to identify the base, the exponent, and the value. So in log form, the smaller the number written down below or as a subscript is the base, right? The number over on the other side by itself is the exponent. And of course we're calling this 5 the value of the expression. We call it V. So now when we switch that, base comes first. Remember, we're writing this now. Base raised to exponent equals value. So base is 25, the exponent is 1/2, and the value is 5. So there it is rewritten. And I'll put a square arrow every time I change from one form to another. So let's do that again. Identify the base. What is it? 64. What is the exponent? 1/3, and that equals 4. Now that one is the opposite of the one we did above. So we already checked that on the calculator, right? This one and this one. Right? We already checked that on the calculator. We know that to be true. Right? Now the last one, again, identify the base. 25. What is the exponent? -1/2, and that equals the value, which is 1/5. Now let's check the last one on the calculator before we close this video. Okay, so let's clear that. Now 25 raised to the power of, open bracket, -1/2, 1 divided by 2. Alright, should be 1/5. Now we get 0.2, but we'll change that back to a fraction. Math, fraction, enter, and there it is, 1/5. So that indeed is a true statement. So there's practice from page 123, switching back from log form to exponential form, and exponential form to log form.